So one of the really cool things we can do with matrices is some cryptography using the inverse of a matrix to help us with encryption and decryption. So if we want to use that, first thing we have to do is create our message including some spaces. And I don't worry about punctuation because of just trying to keep it simplified with the numbers that we may have. And so what I have is I would take and say that 0 is a space, and then I got 1 through 26 being the alphabet. And you could add more options after that for various punctuation if you wish. But this is the most common thing you'll see. After that, I'll create 1 by n matrices to split up my message. So I just want to make sure that I make it a size that's going to be easy to find invertible matrix. Because then what I need to do is find an n by n matrix that's going to be invertible. So you create one or you find one and you know you're going to use that. And I multiply each of those smaller message matrices by the n by n matrix so that I can create my encrypted message. From there, if I know my original matrix that I have that was used to encrypt, I can then find its inverse and use that to decrypt the message. And then I can put it in line and get exactly the message that I want to get. So let's see this in action. Let's say that I have the word last week that I want to encode. And what I can see is that's 4 letters, a space, and 4 more letters. That's 9 total letters. And then that's pretty easy to use 3s because I can split that easily into 3 parts. Now say that had been 10 letters. I could still do 1 by 3s, and my last one I could just put 2 extra spaces, so 0, 0, if I needed to. The other thing I could do is I could use 2 by 2 matrix, I could use a 4 by 4 matrix, and then anything that's left over that doesn't fit exactly, I could just put zeros to represent spaces at the end. So let's change the letters over to numbers. So I've got LAS, that would be my first matrix, T space W, and then my third matrix would be EEK. So take those, change them into numbers, and then I'm going to take those. I need to find a matrix that will be invertible. So you either have some that you know, or you could put some numbers in, try to find its inverse to make sure it works, but you have to make sure it's an invertible matrix. So I know that this matrix works. So now I'm going to take each of my matrices and multiply it by the invertible matrix. Just do basic multiplication, and I look. Now I have these new numbers that make no sense if I see them in a line. So there's that encrypted message. So if someone saw that, I'd be like, I don't know what that means. Unless they have the key, and the key is knowing the matrix that we started with. So say that you're in class and all of a sudden you see your kids hand out this long message, and you happen to find the key, that matrix that will need to be the invertible. So first thing you would do is you would take and separate it into the 3 sections, and you would know what size the invertible matrix is based on by having the key, which in this case is 3 by 3. And if I find its inverse, that's what I have here. Now I'm going to take each message, multiply it by the inverse. And if I go back and put these in line, 12, 1, 19, 20, 0, 23, 5, 5, 11, and I check it back with my key, and I plug it back in, I'm back to last week.